So in this problem we have the three concurrent edges of a tetrahedron. So those are given by the vector a plus b, b plus c and c plus a. So what we'll try to do, let's try to illustrate this particular tetrahedron. Now for the simplicity purpose, we are going to consider one of the edge of the tetrahedron as coinciding with the origin of this three-dimensional Cartesian coordinate system. And we have, so this is the tetrahedron. So let's assume that one of the concurrent side is given by the vector a plus b. Another one is given by b plus c. This is a plus b. And the third concurrent edge is given by c plus a. Then the volume of this particular tetrahedron is going to be 1/6 of. So we'll take the vector a plus b, cross it with b plus c, and then dot the result with the third edge, which is c plus a. Now since this is a scalar triple product, what we can do is we can change the order such that we have 1/6 times. So we can have the vector b plus c, cross it with c plus a, and then dot the result with a plus b. Or this can be also equivalent to, here we can use any one of the result to solve a particular problem. So we have to show that this volume of this particular tetrahedron is twice the volume of another tetrahedron. Now the new tetrahedron has a concurrent sides of a, b and c. So this means we have another tetrahedron whose, let's say this is the other tetrahedron. So its edges are given by vector a, vector b and vector c. So we have to show that the bigger tetrahedron, the volume of it is twice that of the smaller tetrahedron. So let's start the problem. So we'll begin by expanding this cross product. So that will be 1/6 times. So we have a vector crossed with b plus c plus b vector crossed with b plus c. And the result is dotted with c plus a. We have 1/6. So we will distribute a with b plus c. So that will be a cross b plus a cross c plus b. So we'll expand this as well. We have b cross b plus b cross c, dotted with c plus a. Now by definition, b cross b, so this will go to 0 because they are parallel to each other. So we are left with, next what we will do is we will distribute c plus a with this particular expression by taking the dot product. So that will be 1/6 of. So we have a cross b, so that will be dotted with c plus a cross c dotted with c plus b cross c dotted with c, and then we have plus a cross b. So we'll take this a cross b and dot it with a vector, plus few of the terms will vanish. For the second term, a cross c dot product with c, this will go to 0 because when we expand this into the determinant form, we'll see that two of the rows are exactly the same because we have two c vectors here. So this will go to 0 by definition. This will go to 0, this will go to 0, and this will go to 0. And all we have is the first term and the last term that survives. Now if we look at the last term, now by definition we know that our scalar triple product is cyclical in nature. So b cross c dotted with a, this is the same as a cross b dotted with c. So that means we have two same terms. So finally we can rewrite this term here. So this and this will get added to give us 2. So we have 2 times 1/6 of A cross B dotted with C. And this is 2 times the volume of the tetrahedron with concurrent edges given by vector A, B, and C. So this is what we were asked to prove.